Hello learners, welcome to the class. Just give me 1 second, I'll just check if I'm online. Okay, so in today's class, what we're going to see is we're going to see what is a capacitor, right? And we are also going to see what is capacitance. We've done this previously. And whenever you are talking about what is a parallel plate capacitor, that is what we're going to see in today's class, okay? It's going to be a very short, it's not going to be a very long duration class. It's going to be short, but any doubts we have in capacitors that we have done till now, you can actually ask me as well, okay? So with that note, let's begin today's class. Right, okay, so my name is Mohana. I'm a physics educator here at Unacademy. So I'll be basically taking class 11 and 12 physics. Now, my Telegram channel my Telegram group link is given, as well as if you see, I had also given the common ICSC and ISC Telegram channel link as well. So before any class goes live, I will share it in my Telegram group, so you can follow me for the same over here. And as well as now, just like how we have these special classes, right, on the YouTube platform, the free classes, likewise we also have free classes on the Unacademy platform. Okay, so these classes are absolutely free, and you can take any of your favorite educators classes. So we just given them a name as special classes, and you can engage with the educators via pool feature. If you have any doubts, you can actually get your doubts cleared in these special classes, because those classes are also live. Now if you will look in the description box, there would be a link given for my upcoming special class that is going to happen on the Unacademy platform. Okay, now so you can just go there and enroll for the class. Now on 30th July we have a class that is going to be a recap of electrostatics. You can come in, and any doubts you have you can ask. And also what we are going to do is we are going to do some important questions, very important questions from this electrostatic unit. We will cover those as well. Okay, and one of the advantages of taking your Unacademy Plus subscription is that you can learn from the comfort of your home, as well as you get unlimited access to all courses. Meaning whenever you take a course with Unacademy, you are actually getting 4 subjects, that is physics, chemistry, math and biology. Okay, now you will be learning from top educators, and every 4th session, right, meaning after 3 classes, the class after that, the 4th session, will be a doubt clearing session. So any doubts you have, you can, in the classes are anyways live, you can ask your doubts, but after that also, if you have any further doubts on the 4th class, you can again ask. Okay, and we will cover your entire syllabus. There would be there are many practice tests available on the platform, and also every other week there will be a live test series, after which there will be an analysis session with the educator. And the upcoming courses and batches, I'll give it to you shortly. Before that, if you see, whenever with Unacademy, if you're taking a course for longer duration, the price per course goes down. So instead of, if you're taking for 3 months, you have to end up paying 3,306 rupees per month. But if you take a 1-year course, then you're only paying 1,653 rupees per month. All right, now right now on popular demand, we are back with the 20% off. That is, in case if you're taking a 9-month subscription, you anyway only have to pay 14,615 rupees for 9 months for 4 subjects. Okay, you're saving 2,578 rupees. For 1 year, you're paying 16,863 rupees, and you're saving 2,975 rupees. Okay, so here again, to avail this discount offer, you can use my code MTIS10. Now the ongoing course we have is actually the Achievers batch. This course started on 6th July, and any missed classes, if you're registering now, if you have missed any classes, class recordings will be given to you, and during doubt class sessions you can ask your doubts. The course will be taught in English. For physics, we meet every 5:15 to 6:15, Monday, Wednesday, Friday. And again, math, Rahul sir will take. Chemistry, Manisha ma'am will take. Biology subject will be taken by Lakshay sir. And every day, if you see, if we have on Monday, Wednesday, Friday, chemistry followed by physics, and on Tuesday, Thursday and Saturday we have math followed by biology. So in a month, for each subject, you will get a minimum of 10 to 12 classes at least. Okay, minimum number of classes. The class can go even higher number than that, it could go. Okay, but at least minimum 10 classes will be there. Okay, in total, if you say minimum of 40 classes, but which means In a month, you will have more than 40 classes for all of these subjects put together. All right. Similar to that, we also have the Brahmastra batch. This is for class 11. Now, the advantage for you guys is if you're in class 11 and taking a class 12 subscription, class 12 subscription is absolutely free. Again, this is also all 4 subjects. When whatever amount you're paying for is for all 4 subjects. Now, for physics, the class is between 5:15 to 6:15, Tuesday, Thursday, and Saturday. All right. With this note, let's start. Okay. Now, before we go any further ahead, one of the simplest question: what is the unit of capacitance? Right? If you know the answer, you can actually give it. Right? Otherwise, the unit of capacitor is actually farad. Okay. Let's see how. Now, let's say very simple. I'm sorry. Just a second. Right. Okay. Very simple concept. Right? We all know what is a potential. Right? So let's say we have a charge over here. Okay, positive charge. So field lines will be pointed radially outwards. Now, let's say I'm bringing in somewhere from infinity, right? I'm bringing in a test charge, infinity over here. The influence of this charge is not felt. Okay, somewhere from infinity, I'm bringing in a test charge to this point over here. Okay, this is basically what we call as soon as it comes over here, what happens, right? This force, this charge will experience a force in this direction. Why? This is a positive charge. Test charge, unless otherwise specified, it's always positive, right? So it will experience a force in this direction. Why? Both are positive charges, right? So against this force against the electrostatic repulsion of this charge, I am moving this charge. I have brought in this charge. So this is your electric potential. Now, the same charge, if you're moving from this point to this point, right, against this electrostatic potential, you're moving this point from one charge to another. Then we call that as then there's some work has to be done, right, to move this charge. So what is the work done? Let's say this is point A, B. What is the work done to move the charge from point A to point B? Work done per charge. That is called as your potential electrostatic. In this case, on the field line, if you're moving, this is potential difference. From infinity, if you're bringing, then we call it as electric potential. Don't worry. In depth about what potential is, we will do in the next class. Okay. Then, so here if you see, this is your basic concept. No. Now, let's say we have a surface. Okay. Let's say this is a conductor. So initially there is no charges over here at all. Nothing. It's just a plain conductor. Now what you're doing, you're giving some charge to it. What will happen? If you give a particular charge to it, its potential increases. Meaning, initially to bring in this charge, there's not really any potential needed, right? Because there's no more charges. Now, this particular positive charge has field lines everywhere around, right? Now imagine you have to bring in another positive charge and place it over here. What happens? Because they both are positive, if they are unlike, that is one is positive and another is negative, then there will be attractive force. But in this case, since both are positive, what will happen? This will start repelling, right? Obviously, so we have to do some work to overcome this electrostatic force of repulsion, right? So which is basically your potential. Now, so as you keep, let's say you add some charge to it, the potential increases. So as you keep adding charges to the surface over here, what happens? Its potential increases. So how much of a charge you add, depending on its potential will increase, right? So Q is proportional to V. Now this particular Q, to remove the proportionality constant, we introduce the word C over here. This C is nothing but called as your capacitance of a capacitor. Okay, right? So this capacitance of a capacitor, this capacitance is defined as, right, how much charge is required, right? How much charge is required to increase the potential of this capacitor, right, by unit amount, that is your capacitance. So one capacitance is nothing but how much charge do we need to increase the potential of this capacitor by one potential difference, right? To increase the potential of this capacitor by unit amount, right? That is actually gives you your what is the meaning of your capacitance. Okay. this capacitance depends on certain things, right? One is, what is the shape and nature of the conductor? Okay, what shape it has. Then, what is the permeability of the medium around, right? We have a medium around here, means what is the permeability of that particular medium, right? Also, if there is any other charges that are present around. All of these three things, this capacitance of a conductor will depend upon. Okay. Now, if you look at the capacitance of this conductor, right, when you want to define one capacitance, that is, if you give, okay, the capacitance in this case has a unit of farad. Okay. So, if you want to define 1 farad, it means it is the amount of charge, right? About if 1 coulomb charge is given by coulombs, right? So, if you're adding a charge of 1 coulomb to a conductor, okay, and if that increases the potential of this conductor by 1 volt, okay, then we say that particular capacitance or capacitor has 1 farad amount, 1 farad. The value of that particular capacitance of the conductor is 1 farad. Okay, so unit of capacitance is farad, and 1 farad is a really high it's a very high value, right? So 1 farad, if you see, is actually equal to 1 farad. If you see, it's actually 1 farad is equal to 1 coulomb per volt. Okay, so we don't usually use 1 farad because it's a very high unit. Sometimes we use 1 millifarad, or we use 1 microfarad, 1 picofarad. These are the capacitors value that you can see. Milli is 10 to the power of -3, micro is 10 to the power of -6, and pico is 10 to the power of -12. These are the value we'll see, right? So we know what is the value of 1 farad, correct? So here we saw 1 farad is actually equal to 1 coulomb by 1 volt, right? If you want the dimensional formula of capacitance, very simple, right? 1 coulomb is what? Coulomb, in this case, we can write 1 coulomb in terms of coulomb, the unit is for charge, right? Coulombs is not a basic, is not a fundamental unit. You have to express the units given here in terms of fundamental units. But we know current is equal to charge per time. How much charge flows per time, right? So charge is given by coulomb per times, current in terms of amperes. So from here, what we can say, coulombs is nothing but ampere, right? Charged into, a charge is nothing but current into time. So 1 coulomb, instead of 1 coulomb, you can use 1 ampere per 1 ampere second. Okay, so this you can use 1 ampere second. By volt is given by what? 1 volt, when you're talking about 1 volt, we are talking about how much work is done per charge, right? Volt or potential difference is nothing but how much work is done per charge. Okay, so here work done, the unit of, in this case, potential difference unit is volt, work done unit is joules, charge over here is coulomb. Okay, again we know coulomb is given as in terms of ampere seconds, right? What about joules over here, right? This joules, we know work done, you can give it as force times displacement, right? Force unit is Newton, displacement unit is meters. Okay, so this is Newton meter by ampere seconds. So if you substitute Newton meter by ampere seconds here, ampere seconds if it goes on top, you'll get ampere seconds square by Newton meter, right? Again, we have to change this value for Newton again, right? Newton is again not given. It's a derived unit. It's not a fundamental unit, right? So if you write that in terms of fundamental unit, so you will actually get ampere seconds, the whole square, by Newton will be kilogram meters per second square into meter, right? Now try writing this in terms of dimension formula, right? First, mass, if you see, we have a square, right? S square, right? Kilogram, right? Meter square, S inverse 1. So kilogram, when it comes on top, it becomes m inverse 1, right? Kilogram, the dimensional unit is m, right? Capital M. And now it comes up, it becomes inverse 1. Then comes the length. Length is over here given in terms of meters, m square. So here m square, when it goes up, it becomes -2. Next one is seconds. Here we have this s square when it goes up, right? S to the power of -2 when it goes up, it becomes s to the power of 2. So here it will become s to the power of 4. So time in terms of dimension is given as t to the power of 4, and amperes again you can keep it as this is, right? That is the dimensional, that is the letter used to represent amperes. So this gives you the dimensional formula for farad. Okay, now very simple. Let's say we have a capacitor, but it's a spherical capacitor. Now in this spherical capacitor, right, there are what we are going to see is okay, in this particular spherical capacitor, there is charge distributed uniformly around this spherical around the spherical capacitor. Think of like a ball, and on the surface there is charge distributed uniformly around. Okay, now so here if you see, if you're taking the lines over here, right, field lines for a positive charge is pointed radially outwards, right? So the field lines in all these cases will be pointed radially outwards. Okay, if you extend, I'm just extending this line. This being the origin. Okay, now if you see, this sphere has a radius r. Now if you actually see over here, though the spheres are actually, though the charges are uniformly distributed on the surface, we can actually assume, right, that they are because of the field lines, right? I've just elongated the field lines to make it look like it is coming from the center over here, right? So we can assume that it is concentrated at the center of the sphere, though it is everywhere around. Okay, so what will be the potential in this case, right? Potential, what will be the potential on the surface over here? Potential will be equal to 1 by 4 pi, right? Because potential, if you have a positive charge, right, Q, potential for this charge is given by 1 by 4 pi epsilon naught. Just one single charge if you have, okay, it's given by 1 by 4 pi epsilon naught Q by R. Okay, at what point you're moving? Let's say you have a positive charge, right? At this distance r, you want to find what is the potential. Then you will introduce the test charge over here. Okay, so this is given by r. Right, now what we are going to do in the same case only, here we are taking all of these charges. You can assume it, right, like they are all coming from the center of this point. So all the charges that were on the surface, we can actually assume it as they are coming from the center, right? So what will happen to this formula over here? Potential will be 1 by 4 pi epsilon naught, right? 1 by 4 pi epsilon naught, right? In this case, charge Q divided by what is the distance? What is the distance of all of these charges? Right? This distance is R, right? Okay, R. From the center to the surface, we are saying the distance is actually R. Okay, this is your potential. Now, what will be your capacitance? Capacitance is given by potential by volt. Why? Capacitance is equal to, we just saw charge. If you increase the charge in the conductor, its voltage will increase. So remove the proportionality constant. We use this constant called as capacitance C. So C will be Q by V, right? So charge Q, we know this is this value. What is V? V is 1 by 4 pi epsilon naught, because the charge is over here, and in this case Q by R, right? So V will be what in this case? If you see 1 by 4 pi epsilon naught will go up, right? Then Q can cancel and you have R. Okay. So what is the potential of this particular capacitance? Sorry, this value is equal to not V but C. So your potential of this capacitance depends on is proportional to the radius of this conductor over here. Okay, potential is proportional to the radius of this conductor over here. Alright, now let's say, for example, capacitance in this case is 1 farad. Okay, so 1 farad will be equal to, let's substitute for, let's take this, let's see, we want to find what is the radius of the sphere. Okay, so here the radius can be taken as 1 by 4 pi epsilon naught is equal to R. Right, instead of capacitance, we want to find what should be the radius of a conductor if that conductor should have a capacitance of 1 farad. Okay, then if this is 1 farad, this will be 1 divided by 4 pi epsilon naught, right? So 1 divided by 4 pi epsilon naught is nothing but, okay, 1 farad into 1 by 4 pi epsilon naught. 1 divided by 4 pi epsilon naught is nothing but 9 into 10 to the power of 9. Right? So, if you're saying your capacitor should have, which is 1 farad means, right, then the radius should be somewhere around 9 into, right, 9 into 10 to the power of 9 meters, right, or 9 into 10 to the power of 6 kilometers. Okay, this is about 1500 times the radius of Earth. Okay, because the radius of Earth itself is only approximately around 6 into 10 to the power of 3 kilometers. When compared to this, if you want to get 1 farad, then you have to take a conductor which is 1500 times more than that of the Earth. Okay, so because of that, 1 farad is a very large value. We do not use that. We use in terms of milli or microfarad. Okay, now that we know this, right, let's say you have a conductor. Okay, let's say there's no charges given to it, it's uncharged. Alright, now what we are going to do, we are going to give positive charges to one side and positive charges again to another side of this conductor. Now what we are going to do is, right, we're going to bring in another charge. What will happen because of induction? If this is positive charge, this will again become, this is an uncharged conductor, right? You're just bringing an uncharged conductor. This is positive means the charges on this end will become negative. If this becomes negative, this one becomes positive. Alright, now in this case if you see, right, because of these charges, because of this positive charges over here, the net potential of this plate over here decreases by a very small amount. Okay, potential decreases means capacitance will increase, right? Because why? C is equal to Q by V. If potential decreases means capacitance will increase. Okay, so because here why? Positive charges are much more closer than the negative charges, right? Because of this, when you bring in this plate close to this, right, the potential of this plate drops by a small amount, which increases the capacitance value. Now what we are going to do is, we are going to ground this charge over here. If you ground it, what happens? Electrons will start flowing, right? Then all of these charges gets neutralized. So if all of these charges gets neutralized, now we have a capacitor plate where we have positive charges on one side. It will still hold. Why? Because there's negative charges over here. There will be field lines everywhere around over here. So in this case, this capacitor will still hold. Okay. Now such an arrangement is what we call as a capacitor. Okay. Now, alright. So a capacitor is nothing but an arrangement of two conductors which are separated by an insulating medium. Insulating medium can also be an air. Okay, and a capacitor is just used to charge electric charges, and because you're storing electric charge, you're storing energy as well. Alright, so here the representation for capacitor, you could usually, if it has a fixed value. For example, let's say this is 10 picofarad capacitor. It will have a fixed value. But if you see this symbol over here, if the representation is given by this symbol, then it means this charge over here changes. I mean, in this case, the capacitance value can be changed over here. Alright, it's a variable capacitor. Okay, now always remember the charge Q is proportional to V. So Q is equal to C into V. Capacitance is equal to charge by potential difference. Okay, so and we also saw what was 1 farad. Now there are different types of capacitors. Alright, what we are going to see is, let's say we have just like the one we saw, let's say we have two parallel plate capacitors. Okay, they are separated by some distance and the material in between is basically air. Alright, now this particular parallel plate capacitance will have an area of cross section, right? So this is the area A. It will have an area of cross section, right? And also there will be a distance between, there will be some distance between these two plates, right? And what we are going to do, let's say this end over here, it has full of positive charges. Now this is a parallel plate capacitor, right? So if there is positive charges on this end, means then all of these charges together, we can take, for all of this, we can take the charge density sigma, right? Sigma gives you the charge density for how many charges are there in a given, per unit area, how many charges are there. Okay, let's say you have a surface, let's say this is a unit area of the surface. For this unit area of this particular surface, how much charges are there? Okay, so sigma gives you that surface charge density, right? It's a surface charge density because we are talking about area, right? Now the second case, what we're going to do, if this is positive charge, means let's say take this to be negative. So here again, the charge density in this case is positive, means charge density in this case is going to be negative. Surface charge density is going to be negative. Now electric field outside the conductor cancels out, so this is actually equal to 0. Okay, net field outside is actually 0. Outside this capacitor is actually 0. Okay, now inside the capacitor, what happens in this case, if you see, there will be charge coming from negative terminal towards this positive, right? So electric field lines will always be from positive to negative charge, right? So this will be your electric field lines that is formed inside. Okay, now the electric field, because of these two charge, in this case, this will get added up, right? So this electric field, if you're taking, this will be able to, in this case, if you see this particular value, if you take E, this will be equal to electric field in this case, right, will be equal to sigma giving you how much, what is the charge density, right? Charge density per area, sorry, by half of the charge density, right, per what is your permittivity. Okay, this you can get from your Gauss's law, right? Gauss's law states 1 by the value it gives is charge per permittivity, right? So that is what we have taken over here. Sigma being, it is the charge density in this case for surface, right? So this will be sigma by 2 epsilon naught, right? So similarly for the other side, right, for this plate over here, we can have sigma by 2 epsilon naught. So together what you will have is, this electric field gets added up, you will have sigma by epsilon naught. Okay, so in this case, right, in this case, if you see towards the end, right, towards the end, if the plates have a finite area, right, if they have a very finite area, small area, right, finite area, towards the end you can see the ends of the conductor, what you can see is the field lines are not straight but a little bit bent. So that is something what we call as fringing of the field. Okay, right. Good evening, Abhishek. I'm fine, thank you. How are you, Abhishek? Right, so here if you see, okay, now all right, now if you see, these two plates are separated by a very small distance also, right? So here now the potential difference between these two plates, okay, what we are going to say is the area of the plates is extremely large when compared to the distance squared. Okay, but if you have, in that case, you will get a uniform electric field. When compared to this distance, if the area of this plate is actually very large, means you will get a uniform electric field. In such a case, if you see, we want to find potential difference, right? In that case, we want to find capacitance value, right? For that, we want to find potential difference, right? So what will be the potential difference between the plates, right? Potential difference between the plates will be Abhishek, for CBSE and JEE main exams, this particular question you're asking? All right, Abhishek, thank you for that. I'll tell you, Abhishek, in the next class for JEE mains, if you're looking for Gauss's law, I'll tell you in the next class what is the percentage of marks, right? I'll check for it and I'll give you a weightage for it. Okay. Now this particular potential difference we know, in this case we know the electric field and the distance between the plates. So potential difference in this case, so we can take the potential difference between the plates, that is actually V, right? V will be equal to what is the electric field times the distance between the plates, right? This basically gives you your relationship. Remember, the potential gradient will be given by electric field is equal to the negative of the potential gradient. You would have seen in the earlier, right? Meaning wherever the potential is in the potential is wherever the potential of because of a charge is steeper, electric field will go in that direction, right? So E is equal to, we know actually what electric field is equal to potential by the distance or displacement, right? In this case, if you see from there, if you take potential will be electric field into distance. Electric field we know is sigma by epsilon naught, right? Into distance is d again. Okay. Now from here, if you take what is the capacitance of this parallel plate, right? So capacitance is given by Q by V, right? So Q is nothing but charge. What is the total charge density over here? Now see, charge density is given by how much charge is there, right? What is the total amount of charge is there per unit area. So total charge will be what is your surface charge density into area. So charge will be surface charge density into area by potential, in this case a surface charge density by a permittivity of free space into D, right? So if you take over here, this will give you permittivity of free space A by D. Okay, this gives you the potential of this parallel plate capacitor. This gives you the capacitance of your parallel plate capacitor. So capacitance, the C, is proportional to area of the plate, meaning increase the area of the plate. Instead of taking a smaller plate, you can take a parallel plate capacitance. If you're taking a larger plate, then actually if you increase the area of the plate, the capacitance increases. Okay. Similarly, capacitance again is proportional to permittivity of the medium. So if you change the right now what we've taken is air, right? In this case, air is the medium. In case if you're using some other medium other than air, or if it is in vacuum, instead of free space, if you're changing some other medium in between, if you're placing some medium, that will again include the that will also increase the capacitance value. And formula of area in the sense, you mean that will be given that will depend on the question, what is the area information they have given. Alright, depending on this you can substitute when the question is asked. Let's say the parallel plate capacitor they have taken is in a rectangular shape. Then the area of that particular shape, again depending on the question you can substitute in this value. Right now, and this particular capacitance is also inversely proportional to the distance between them, meaning decrease the distance, capacitance increases. Increase the distance, capacitance will actually go down. Okay, these are the three things capacitance of a parallel plate capacitor will depend on. Okay. Okay, see, very simple question you can do in this case is, let's say you have two conductors. For example, let's say you have two conductors, okay? Just two conductors, not parallel plate or anything. You just have two conductors, okay? Now, let's see, and let's say this charge, let's say you are transferring 1 into 10 to the power of 12 electrons, okay? You're transferring that from one conductor to another. So many electrons you're transferring, okay? From here, okay, because of this, if the potential difference developed between these two ends, right, because of that potential difference developed between these two ends, right, that potential, if that particular potential is actually around 10 volts, means we want to find what is the capacitance. Okay, you can actually find the capacitance value very easily. All right, all what you have to do is, in this case we know how many electrons are going, right? That gives you what is the charge nature. Electrons in this case, right? This is 10 to the power of 12 electrons. From here, we know what is the value of this electron. What we got is electron, right? That you can actually take it as 10 to the power of 12 electrons are given. That is the number of electrons is given. Number of electrons, how many number of electrons is transferred is given. So what will be the total charge that is transferred? That you can use Q is equal to N into E. Okay, then Q is equal to, it's a conductor. So when you're transferring the electron, you can transfer it by some means, right? You can charge from this conductor to this conductor through a wire, right? Using electrostatic induction, right? You can charge through that also. Frictional electricity, through that also you can charge this particular conductor, right? Or you connect two wires between them. Then charges can transfer from one end to another. Let's say this has more number of electrons and this does not have thus much. This is at lower potential and higher. This is at a higher potential. Connect by wire. Some amount of electrons will transfer here. So you can actually transfer this charges, right? So there's two capacitors and you're transferring its charges. 10 to the power of 12 charges you're transferring. So the total charge of this capacitor, total charge transferred will be number of electrons, that is 10 to the power of 12 into how many what is the charge of an electron, right? That is 1.6 into, that is actually correct, Abhishek, that is actually right. So the total charge, if you take, charges in this case will be 1.6 into 10 to the power of, in this case if you take, this will be minus 19, right? Minus 19 minus plus 12 is minus 7 coulombs. This becomes the charge right now. Now, so much charge is given from one conductor to another. Right, now we want to find the capacitance of this capacitor, right? So the capacitance is given by charge by potential difference. Charge is 1.6 into 10 to the power of minus 7 coulombs. Potential difference, if you take, potential difference is given in this case as 10 volts. In the question itself, we initially saw potential difference was 10 volts. So if you solve for this, the capacitance value, if you see, this will be somewhere around 1.6 into 10 to the power of minus 8 farad. This will be the value of the capacitance for that particular capacitor that you have taken. Alright, now other than this particular capacitor, right, whatever we saw was a parallel plate capacitor, right? There are two more shapes that we can see. One is basically your spherical capacitor, another is your cylindrical capacitor. Okay, now the spherical capacitor, if you're taking, let's say this one, right? Okay, let's say you have a charge. Very simple. Okay, let's say you have a capacitor which is in the circle, right? Which is in the circular form, and let's say the charges over here is negative, right? Enclosing this, you have another capacitor and the charge inside this capacitor is positive. Now this becomes your spherical capacitors. Spherical meaning spheres, right? Right? Spherical. Think of, you have one ball, on top of it you are actually covering it with another one. Right? Sometimes you have seen a balloon inside another balloon, right? Likewise, you have a smaller sphere, on around it you have another sphere. Okay, the sphere inside has this particular charge, that's negative. Sphere outside has a positive charge. In this case, it is having positive charge. Okay, now field outside is 0. Field outside in this space also, field is 0. Okay, but from the center to this sphere, the distance is A. From the center to this sphere, the distance is, let's say, around, you can take that distance as B. Okay, this is the distance of this particular sphere that we have taken. Now, in this case, what we are going to do, the charge, if you see, it's going to be from the positive to the negative terminal. Right, the electric field lines are going to be from positive to negative terminal. So it's a negative charge, right? So it's going to be pointed radially inwards. So this is going to be in this, the field is going to be in this direction. All right. So if you want to find out what is the electric field at any point inside over here, you can choose any point, let's say point P over here. Okay, you want to find out what is the electric field at this point P over here, which means to do that we have to make use of Gauss's law. Okay, then that Gauss's law, right? So for that we have to take a Gaussian surface. So it's an imaginary surface, right? And the Gauss's surface has a particular value also, right? So here what will happen then, according to Gauss' law, your electric flux will be equal to electric field times the area. Area of this particular sphere, this is at a distance r. Okay, So area of this Gaussian surface, if you take, that particular surface has an area of 4 pi, because it's a sphere, 4 pi, in this case we are not using capital R, right? Yes, small r, 4 pi r square. Okay, so this value according to flux at this point, right, is given by electric field into area. Okay, flux is how many field lines are flowing through that particular area over here. For this point P, at this point, if you draw an area of cross section, let's say there are field lines everywhere, and at this point, right, you are saying at this point vertically you drop an area and saying how many field lines are going, right? That will basically be equal to how many field lines are going times the area. That will give you your flux, right? At this point we found the flux. According to Gauss's law, this particular flux, right, electric flux is equal to what is the charge, right? Charge by permittivity, right? That is your Gauss's law, right? 1 by epsilon naught times the permittivity times the 1 by epsilon naught, that is inverse 1 by epsilon naught times the charge enclosed by that particular space, right? So in this case, what we are going to do at this particular point, instead of this charge Q, we will use a capital Q over here, right? Okay, now instead of this phi, we can equate these two equations, right? We can equate these two equations, that is electric field Alright, so from here if you see what is your electric field, you will get the electric field equation as Q by 4 pi epsilon naught into R square. That will become your electric field equation. Now we know the electric field. How do we get the potential at this particular point over here? Now if you want to get the potential, it is very simple, right? We know electric potential is nothing but, if you want the potential, right, this potential will be see, if you want a potential at this particular point, because of the very small amount of charge over here, that will be minus E electric field at that point into that particular distance R. Now if you want the electric field because of the entire surface, that is potential is equal to field into dr, right? So because at this point and on the surface, if you want the total potential, okay, meaning between these two shells that we are seeing over here, between these two shells, what is the potential you want to see? Okay, for that we will say that potential is nothing but minus, we are going to integrate, this distance is A, this distance is B, right? This shell distance over here is basically A and this shell distance over here is B. So we have to integrate between, right, A to B, E, right, electric field times dr, that is the position vector that you are taking in this case. Okay, so this will be nothing but electric field times dr, right? So this negative sign will in this side, if you see, this will be again, right, E dr, right? Because electric field and dr over here, right, that is the displacement, are in opposite to each other. So that will be in the terms of cos almost 180 degrees. Okay, if electric field lines are in this direction, means, see, the field lines are going in this direction, electric field lines. Now if you see the displacement, the distance that you're taking, the displacement if you're taking in this case, what is the distance? The r vector, it is coming in this direction, dr. So one is in this direction, another is in this direction. Angle between them is 180 degrees. Okay, if angle between them is 180 degrees, what will happen in this case is, if you take E dr cos 180, cos 180 is minus 1, you get minus E dr. Okay, so minus into minus, if you substitute for that, you will get E dr. Okay, so we have just done the vector equation over here. So this will be E dr, okay, right, E into dr, right? So E value over here, if you see, we actually got it. We got the E value as Q by 4 pi epsilon naught r square, right? Now this value you can actually take it outside. So all you will have is, right, all you will have is this value, right, times A to B, we'll have 1 by r square, right, into dr. We will only, because the rest are constant, we will only integrate this. Now 1 by r square into dr, if you integrate, you will actually get minus 1 by r. If you integrate this, you will get minus 1 by r, right? This 1 by r within the limits a to b. Okay, so if you actually rearrange this and if you write, you will basically get, okay, you will basically get q by 4 pi epsilon naught, right? 1 by a minus 1 by b. This is your charge q. This is your potential difference v, right? Now capacitance is going to be charge per potential. So this is q by this value, q divided by 4 pi epsilon naught, right? 1 by a minus 1 by b, right? Or you can actually solve for this and you can write 4 pi epsilon naught, right? Multiply, inside you have to multiply. So this will become AB term will come on top, and here you will have B minus A. So this is the capacitance for a spherical capacitor. Alright. Okay. With this note, we are actually coming towards the end of today's class. Let's meet in the next class. So once again, we actually have a special class for electrostatic units on our Unacademy platform on 30th. Before that, we will again study, before that we will also do in the next class potential and capacitance, right? What do you mean by potential difference, electric potential, and what do you mean by potential energy, right? All of these three we will see in the next class along with numerical, so do join in for that class as well. Now there's a 20% off on your ISC board plus subscription that is going on right now because of popular demand. It is back. So if you're taking 1 year subscription, you only have to pay 16,863 rupees and you can get 2,975 rupees off. Okay, for this you can actually use your code you can use my code to get the offer. You can use my code MTIS10. Alright, similarly for 9 months you just have to pay 14,618 rupees and you will save this 2,578 rupees. Okay, so you can go with the 1 year subscription or a 9 year subscription for class 12, right? So for class 12 we have an ongoing batch. The batch name is Achievers. The target of this batch is going to be completing your first term syllabus and then we move on to your term 2 syllabus. Okay, this term will be taught the course will be taught in English. For physics, we meet every 5:15 to 6:15, Monday, Wednesday and Friday. Math, Rahul sir will take, Manisha ma'am will take chemistry, and Lakshay sir will take biology. Alright. Now, likewise for 12, for class 11, we have the Brahmastra batch. Again, the focus of this batch is your midterm syllabus coverage. For physics, we meet every 5:15 to 6:15, Tuesdays, Thursdays and Saturdays. Okay. Now, you can follow me on my community. So go down to the description box, go to the community channel. There will be some MCQ types questions asked from your first 5 units. Do try attempting them. In any of the educators video, if you're seeing any inappropriate content and if you are reporting the same, you can claim a prize, right? And thank you guys. I'll see you all in the next class. If you like the class, please share it among your friends, subscribe to the channel and also click on the bell icon to get notification. Alright, see you all.